Hello friends, welcome to Shiksharthi. In this video, we shall be solving questions 4 to 7 of exercise 8.3 on trigonometry. So let's start. Question number 4 says, if tan A is equal to cot B, prove A plus B is equal to 90 degrees. We already know this from this table. We already know this. So sometimes what happens is the things that we know for sure, it becomes difficult for us to prove. But the time when you're learning things for the very first time, if you had proved it then it becomes very easy for you to prove it now when you are being tested to prove it. So the best way which I feel should be, which is required to solve this question is just draw this piece of information. Now from the question it is pretty sure that none of these two angles is equal to a 90 degree. So let us say this is angle A, this is vertex A, this is vertex B, and this is vertex C, right? And this is perpendicular, this is base, and this is hypotenuse. So from here it is already given that, so what is the value of tan A? Tan A we know is perpendicular upon base, right? At the same time, if I have to calculate cot B, how much is cot B from here? Cot B, let's say this is B and this is angle A. So cot B, this is angle B, let's say. So cot is base upon perpendicular, which is perpendicular upon base only, eventually. Now it is given that both of these are equal, which is true. But when would these two be equal? So these two would be equal only when angle A, let's say, plus angle B plus 90 degrees, plus a 90 degrees is equal to a 180 degrees, right? So you will say angle A plus angle B is equal to 90 degrees, hence proved. This is the best way in which you can prove this. I hope you understood. So let's move on to question number 5 now. So question number 5 says, if sec of 4a is equal to cosec of a minus 20 degrees. I hope you heard it correctly. I never said sec of a. I said sec of a. So if sec of 4a is equal to cosec of a minus 20 degrees, where it is already given in the question that this angle 4a is an acute angle, find the value of a. Question number 3, which we have done in the earlier video of the same exercise, is more or less the similar kind of a question, more or less. Okay, so there are two ways of attempting this question as we had talked about that question. So the first way is, let us talk about the basic way. We know that sec of a is equal to cosec a, and cosec of a is equal to sec, given that both these angles are complementary. So can I say sec of 4a can be written as cosec of 90 degrees minus 4a? So which is just like saying cosec of 90 minus theta is equal to sec of theta. Okay, so now this can be written as cosec of a minus 20 degrees. Now you have to be very attentive at this step, because since it is given that the angle 4a is an acute angle, which is why, when 4a is an acute angle, the remaining angles except for 90 degrees, the remaining angle will also be an acute angle. It is then only that you cancel it out on both the sides, and you say what? You say that 90 degrees minus 4a is equal to a minus 20 degrees, and then you solve this. So when you solve this, what do you get? So can I say 5a is equal to 110 degrees, and then we finally say what? A is equal to 22 degrees. This is one of the ways of doing it. Now let us check the answer with the help of another way that we already know. What is the way that we already know? If I draw a right angle triangle, which I have drawn here, in that case we know that one of the angle, let us say this angle is 4a, and this angle was given to you as acute. So in that case the other angle will also be acute if this angle is 90 degrees, right? Okay, so now since we are talking about a right angle triangle only, so we will say that the sum of these two angles will also be equal to a 90 degrees, which is just like saying the sum of 4a plus and the sum of 4a and a minus 20 degrees should be equal to a 90 degrees, which is just like saying you're saying the same. So you're saying what? 5a is equal to 110 degrees. So a becomes equal to how much? 22 degrees only. So I feel that these are the two ways of attempting this question, wherein this method should be adopted for an objective question. You can adopt it for a subjective question given that you specify, you draw the diagram and you tell them. Or you can use this method. But in this method also you need to be attentive and tell that I can cancel a cosec from both the sides only when it is given that one of the angle is acute, and if of a right angle triangle, if one of the angle is acute, then the other angle will be acute as well. Right? Let's move on to the sixth question. So talking about question number 6, it says if ABC are the interior angles of a triangle ABC, then show that sine of B plus C by 2 is equal to cos of A by 2. For this, let us draw a triangle first. Now nowhere do they mention that this is a right angle triangle, so we will not assume it to be a right angle triangle unless it says that it is a right angle triangle. This is one thing. Other thing is, now since you are doing a question on trigonometric ratios, so you know that you talk about trigonometric ratios inside a right angle triangle only. But in the exam you do not know that they are talking about a right angle triangle, which is why we are taking a generalized approach. Though we could have taken a specific approach also, and the specific approaches I could have taken one of the angles as 90 degrees, but in that case you have to be very sure of which angle are you taking. So for example, if I say this is angle A, in that case this becomes angle B and this becomes angle C. So either you make two cases here and then solve, or you can just take a general case, because this case will fall under this category only. Okay, so we know that the sum of all interior angles of a triangle is equal to 180 degrees. Now we need to have A on one side and B plus C on the other side. So can I say that this can be written as A is equal to 180 degrees minus B plus C, and then I divide both the sides by a 2. So in that case, what am I getting? I am getting A by 2 is equal to 90 degrees minus B plus C by 2. So now from here I can use, once I am very sure of the fact that one of the angle is a right angle triangle, it becomes easier for me not to assume a particular case. So now can I take the cos of this? So if I take the cos of this, is just like saying cos of A by 2 is just like saying cos of 90 minus theta. Let's say this is theta, and we know that cos of 90 minus theta, cos of 90 minus theta is equal to sine theta from this table. So either I take this or I take this, right? So can I say this can be written as sine of B plus C by 2? Of course. So from here you are able to prove that cos of A by 2 is equal to sine of B plus C by 2. Now the question arises here is, what if I would have taken this case? In that case it becomes highly specific, and when you are solving a question, it should be solved in a generic way, not in a specific way. But even if you take this, you will be able to prove that even here also it should hold good. How? So this becomes cos of 45 degrees. How much is cos of 45 degrees? How much is cos of 45 degrees? 1 by root 2. So you will say that the right hand side value is 1 by root 2. Now B plus C by 2 is just like saying 90 degrees divided by 2 is again sine of 45 degrees. So you will be able to say, even if you would have taken this as a right angle triangle also, then also you would have been able to prove that LHS is equal to RHS. So in either of the cases you could have proved this identity, this equation. Right? Let's move on to the last question, which is question number 7. So question number 7 finally talks about express sine 67 degrees plus cos 75 degrees in terms of angles between 0 to 45 degrees. I feel that by now, since you have already attempted 6 questions, this question should not be a difficult one for you. Shouldn't be. How? Can we say that sine 67 degrees can be written as cos of 23 degrees? Yes. Can we say that cos of 75 degrees can be written as sine of 15 degrees? Yes, using the complementary angle theorem. And when we know that we are adding this, we will be adding this as well. So sine 67 plus cos 75 degrees becomes equal to how much? Cos of 23 degrees plus sine of 15 degrees. And then if you wish, you can convert it into other trigonometric ratios also. For example, you know that sine is 1 upon cosec, cos is 1 upon sec, and so on. Right? I hope all these questions that we have done, I mean question number 4 to question number 7, have been understood by you fairly. If you haven't understood, please go through the video once again, and if you still have doubts, please put it in the comment section so that we can reach you as soon as possible. If you feel that something very informative has been discussed in this video, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you start receiving updates from us regularly. If you want us to do some videos on some specific topics or difficult topics, please put it in the comment section so that we can do it for you. Thank you so much. Until next we meet, goodbye.